Hey friends, welcome back to the channel, and in this video let's discuss about message streams. And most popular message stream is Apache Kafka. Let's discuss about both of them. And message streams are quite similar to message queues. So first, let's just revisit what are message queues. So basically, we have two kind of request, synchronous and asynchronous. Whenever client make a request and we serve it immediately, that is called as the synchronous request. For example, opening up YouTube app and you see your feed. That is a synchronous request because you requested for the feed and you got it. Whereas if we have something called as, let's say, uploading a YouTube video, and you let's say update it in 1080p, and it is going to then have different versions, that is 480p, 720p, 1080p, like that. So this is a kind of request that can take some time, and all these requests happen asynchronously. So what you're going to do is, as a client, you're going to upload a video and then just go away. You can close the browser, application, etc. And the YouTube has just put this message in its message queue that we need to render or sort of convert it into different formats for different resolution sizes, 480p, 720p, and 360p, like that. And these are the asynchronous requests, and all of these messages are put up in a message queue like RabbitMQ, etc. Now, these message streams also are quite similar to message queues. So let's understand it with the help of an example. So let's say you are building up a blog site, for example medium.com, and whenever a user publishes a blog on that website, we have to do two things. Not just two things, but for example's sake, we need to do two things. So first is we are going to index it so that it can be searched across the internet. And second, we are going to increase the user's total post count by 1. Now in this case, what will happen is, if you're using a single message queue and we have put up a message of doing these two things in our queue, now this message is going to be read by a consumer. And in this case, what can happen is, if the indexing of the article is done, but when it was doing the update of the user's total posts, it was going to update the database, the system crashed, the consumer crashed, or the database crashed. Now in this case, what will happen is we'll see the inconsistent data. The second approach is going to be that API servers writes to two queues. First queue, which is the message related to search, goes to Q1, and message related to count goes to Q2. But in this case, what happened is, let's say the API server write to this Q2 crashes, and the API servers are not able to do that. In this case, again, we'll still face the inconsistent data. Now to solve this problem, what we actually need is, the API servers should write to one, and this one message should be read by multiple consumers. So for this, we have message streams, and most popular message stream is Apache Kafka. And in this case, what will happen is, API servers are going to write once to our message streams that a blog is published, and Kafka has different topics. And in this case, we can have an example as topic is on publish or blog published. So and each topic has different kind of partitions that we'll cover later. So for each topic, we have a blog published, we have a message, and this particular message will be read by the consumer, search consumer, and the count consumer. So this is actually solving our requirements, which is, it is written by one and read by many, and each consumer can read it at their own pace, and messages are going to persist. So if the messages are read by single consumers, the messages are going to still persist unless we define some kind of expiry on that. Now let's quickly go through the differences between message queue and the message stream. So for the message queue, we have one message and one consumer. All consumers are homogeneous. Messages are deleted after the consumption, and we cannot have different consumer types. But in case of message streams, we have one message but many consumers, we have different consumer types. Like here we have seen like search consumer, count consumer, messages persist. So it is not like the message queue. When the message is consumed, it will be deleted. It is not going to happen like that. And each group tracks their own offset. So let's say this search consumer is faster, is slower than the count consumer group. So for example, count consumer group has processed 5 messages, but search consumer has only gone through single message. So both of these consumers are going to keep track of their last consumed message like that. Now let's discuss about the Kafka architectures. So as I told you that there will be a topic for the message stream. In our case, we are taken as blog published, and each topic will have separate partitions. So we can have something called as hash based routing. Maybe based on user ID, we'll simply hash it with a 3, and whatever we get, we are going to get our messages into different partitions. Now, each message are then going to be divided into these partitions, and from each partition, consumers are going to take up those messages. And for that, we need to have number of partitions should be should be equal to number of consumers to get the best results, because each consumer, so let's say we have a consumer 1 for partition 0, consumer 2 for this partition 1, and consumer 3 from partition 2. Now for this case, it is an ideal scenario in which we have a one-on-one mapping. If we have more number of consumers, the excess consumers are going to sit idle, and if we have less consumers, that single consumer will be overloaded with all the message requests from the different kind of from different partitions. So just to revisit, what is going to happen is API servers are going to write different messages in our message streams. Then these messages are going to be ordered in a topic, and in each partition's topics, in each partition, messages are going to be ordered, but there's no ordering guarantees in case of different topics. And each message is then taken up by the consumer, the search consumer, and the count consumer. So this was on the higher level what is message stream, and what is the essential properties of Apache Kafka. And the key takeaways of this video is going to be the differences between message queues, message streams, what are partitions, how consumers are going to interact with the messages, what are the ordering guarantees within partitions and not across topics, and how we can scale it. So this was the whole discussion about the message streams. So that is for today's video. See you in the next one.